Greetings, everyone. Welcome to the presentation on the history of computer hardware. My name is Dan McElroy at San Jose City College, and I am your guide. I will tell you stories here of how we got to the computers of today. Not only the boxes and the hardware of the years yonder, but even more importantly, of the people who were the creators of these incredible inventions. To be really honest about history, I had a hard time being inspired by the things that happened centuries ago, like the story of how Pope Leo the Great saved Rome from being sacked by Jabba the Hun, or was it Attila the Hutt? I cared less about memorizing the names of King Henry VIII's wives and whose heads he had chopped off for not giving him a son. I took history classes in school because I had to. Now that I am older, I have a greater appreciation of history and have come to really enjoy it, especially the history of computers. If you can, you definitely need to visit the Computer History Museum in Mountain View, California. I used to bring my classes there when I taught on campus. This is a museum that has done things right. Call or check online for the days and hours of operation before going. I am here to tell you the stories of the evolution of computer hardware. I have been personally involved in many of the things described here or have worked with friends who have. Many of these stories aren't in the typical textbook, but they form an intricate part of my life. In college, we learned how to use a slide rule for math calculations and how to build computer circuits out of vacuum tubes. I programmed computers with no disk drive using a teletype as the input-output console and its paper tape reader and punch to edit, store, build, and install software. I've worked on multi-million-dollar systems and with microcontrollers that only cost a few dollars. We had to write the entire programs for some systems because absolutely no software was available. When I started in computers, there were no PCs, Apple IIs, cell phones, or internet. There were no commercial jet airplanes, satellites, color TVs, or YouTube. I have seen the abacus in action. I was totally amazed by the speed of the street vendors in Japan at how fast they were with the abacus. The abacus has a collection of rods with beads that can slide up and down on them. When adding numbers and the top row becomes a 10, then set it back to 0 and carry a 1 to the next column. The first column shows 5 plus 1 equals 6. The next column is a 3, then a 0, 2, 5 plus 2 equals 7, 1, 5 plus 0 equals 5, 4, 0, 5 plus 3 equals 8, for a total value of 6,302,715,408. I had to take a half-unit class on how to use the slide rule. Most of the engineering calculations for the Apollo program were done using only a slide rule. When I was in college, a good slide rule cost about $50, which is about $310 today. The HP 35 was introduced in 1972 at $395, equivalent to about $2,500 today. It was an instant success. For another $50, you could purchase a mounting block and bolt it down to your desk. The TI-30 was introduced 4 years later for $25, driving down the price to $100 for the HP 35. It sold for less than the cost of a professional-grade slide rule. The TI-30 sold an estimated 15 million units during its lifespan from 1976 to 1983. The scientific calculators were 10,000 times more accurate than a slide rule, destroying the business for slide rules. Now you can get a full functioning scientific calculator as an app on your Android or iPhone, making both the slide rule and scientific calculators obsolete. Charles Babbage is credited for inventing the first mechanical computer, the difference engine, and is considered by many people to be the father of the computer. He died before the difference engine construction was completed. While Babbage's machines were mechanical and unwieldy, their basic architecture was similar to a modern computer. The data and program memory were separate, operation was instruction-based, and the control unit could make conditional jumps, and the machine had a separate input-output unit. Commonly referred to as Ada Lovelace, her full name and title was Augusta Ada King, Countess of Lovelace. She first met Charles Babbage in June 1833 and invited her to see the prototype for his difference engine. She was chiefly known for her work on his machine. She was the first to recognize that the machine had applications beyond pure calculation and to have published the first algorithm. As a result, she's often regarded as the first computer programmer. In 1801, Joseph Marie Jacquard developed a loom in which the pattern being woven was controlled by punched cards. The series of cards could be changed without changing the mechanical design of the loom. This was a landmark point in programmability. Herman Hollerith's invention of the punched card tabulating machine marks the beginning of the era of mechanized binary code and semi-automatic data processing systems. Hollerith's punch cards reduced the time to compute the 1890 census from 8 years to 6. Hollerith founded a company that was amalgamated in 1911 with several other companies to form the Computing Tabulating Recording Company. Here is a deck of punch cards held together by a rubber band. I can see on the top that the person has marked different sections of the cards with the names of the parts of the program. The slashed line is there to help put the cards back in order if the deck was dropped. When we were using decks of cards, one of the programmers was very artistic and drew a fantastic picture on the top of the cards. Unfortunately, as the program was updated, new cards were added to the middle of the deck and messed up his picture. I could see his mental challenge as to what was more important, his artwork or fixing the program. Warehouses the size of football fields ended up being used to store punched cards full of important information. Good luck finding the piece if you needed to. Something needed to be done to improve this situation. Eventually, almost everything was done using punched cards: census record, inventory control, paychecks, savings bonds, and more. IBM sold or leased the 026 card punch, a card sorter, another machine for collating 2 stacks of cards into 1 stack, and another machine, the 407 tabulating machine, for computing and printing results from processing the cards. The collection of these individual machines were called the unit record equipment. While at El Camino College in Torrance, California, we were taught how to program the 407 by moving wires around on the removable plug boards. I worked part-time at the post office and put my paycheck in the 407 to see what would happen. But I put it in crooked and my paycheck got damaged, but not destroyed. I never did that again. There were 3 parallel streams of computer development in the World War II era. The first stream largely ignored, and the second stream deliberately kept secret. The Z3 was a German electromechanical computer designed by Konrad Zuse in 1935 and completed in 1941. Zuse worked in isolation from other computer developers and was not aware of the work being done in Britain or America. Many people consider him as the inventor of the computer. Zuse asked the German government for funding to replace the relays with fully electronic switches, but funding was denied during World War II since such development was deemed not war important. The original Z3 was destroyed in a 1943 Allied bombardment of Berlin. As a consequence, almost no one heard of the Z3 for many years. The Enigma machines were a family of portable cipher machines with rotor scramblers used by the German military during World War II. A few captured Enigma machines allowed them to be reverse engineered and the ciphers to be decoded. The Bombay was an electromechanical device used by the British cryptologistics to help decipher German Enigma encrypted secret messages. The U.S. Navy and the U.S. Army later produced their own machines to the same functional specification, but engineered differently from both each other and from the Polish and British Bombays. Colossus was a set of computers developed by the British codebreakers to help cryptanalysis. Colossus used thermonic valves that Americans call vacuum tubes. Colossus is thus regarded as the world's first programmable electronic digital computer, although it was programmed by switches and plugs and not by a stored program. The use of these machines allowed the Allies to obtain vast amounts of high-level military intelligence from intercepted messages between the German High Command and their army commands throughout occupied Europe. The existence of the Colossus machines was kept secret until the mid-1970s. British Prime Minister Winston Churchill ordered them to be dismantled into such small parts that their use could not be inferred. Alan Turing was an English mathematician, computer scientist, logician, cryptanalyst, philosopher, and theoretical biologist. An annual award for computer science innovation is named after him. His best-known achievements in computer science are related to the top-secret cryptanalysis breaking of the German codes during World War II, and for his early contributions to artificial intelligence. It is estimated that his work shortened the war in Europe by more than 2 years and saved over 14 million lives. Turing was prosecuted in 1952 for homosexual acts. The Larouche Amendment of 1885 had mandated that gross indecency was a criminal offense in the United Kingdom. He accepted chemical castration treatment as an alternative to prison and later died from cyanide poisoning in 1954. An inquest determined his death as a suicide, but known evidence is also consistent with accidental poisoning. In 2009, following an internet campaign, British Prime Minister Gordon Brown made an official public apology on behalf of the British government for the appalling way he was treated. Queen Elizabeth II granted Turing a posthumous pardon in 2013, and the Bank of England has authorized Alan Turing to be the face of the new £50 note, which went into circulation on 23 June 2021, which coincides with his birthday. John Mauchly and J. Presper Eckert designed the ENIAC at the University of Pennsylvania. It was completed in 1945. It was the first programmable electronic general-purpose digital computer. Although the ENIAC was designed and primarily used to calculate artillery firing tables for the United States Army's Ballistic Research Laboratory, its first program was a study of the feasibility of a thermonuclear weapon. It had a speed on the order of 1,000 times faster than that of electromechanical machines. The ENIAC calculated a trajectory in 30 seconds that took a human 20 hours, allowing one ENIAC to displace 2,400 humans. According to an interview in 1989 with Eckert, we had a tube fail about every 2 days and could locate the problem within 15 minutes. In 1954, the longest continuous period of operation without a failure was 116 hours, close to 5 days. EDSAC was completed at the University of Cambridge in England in 1948. EDSAC stands for Electronic Delay Storage Automatic Calculator. Even before the construction was completed for the ENIAC, Mauchly and Eckert came up with new designs for better computers. The EDVAC, Electronic Discrete Variable Automatic Computer, was one of the earliest electronic computers and was binary rather than digital. The UNIVAC became a commercial success. UNIVAC 1 of 1951 became known for predicting the outcome of the U.S. presidential election the following year. This is noteworthy because the computer predicted an Eisenhower landslide over Adlai Stevenson, whereas the final Gallup poll had Eisenhower winning the popular vote 51-49 in a close contest. The prediction left the CBS News to believe that the computer was in error, refused to allow the prediction to be read on the air.
So let's go down to Philadelphia and see whether we can get an explanation of what happened to UNIVAC from Mr. Arthur Draper, who is the head of the new products division of Remington Rand's Laboratory for Advanced Research. Art, what happened there when we came out with that funny prediction?
Well, we had a lot of troubles tonight. Strangely enough, they were all human and not the machine. To start a prediction like this, you have to assume certain facts about past trends. When UNIVAC made its first prediction with only 3 million votes in, it gave 5 states for Stevenson, 43 for Eisenhower, 93 electoral votes for Stevenson, 438 for Eisenhower. We just plain didn't believe it. So we asked UNIVAC to forget a lot of the trend information that we had put into it, assuming that that was wrong. So UNIVAC worked on a smaller margin of knowledge. This won't give a wrong answer, but it'll throw the odds to the extent that you saw. As the prediction, as more votes came in, the odds came back, and it was obviously evident that we should have had nerve enough to believe the machine in the first place. It was right. We were wrong. Next year, we'll believe it.
Thomas Watson Sr. originally worked at National Cash Register, also known as NCR. When I was young, I only saw NCR cash registers in stores. Although NCR was known especially for treating their employees well, they weren't as kind to their competition. According to an unauthorized biography, Tom Watson was moved into the Dirty Tricks division of NCR, where his job was to run competitors out of business. This had a two-pronged attack. Clones of competitors' cash registers were built, but built poorly to give them a bad reputation. Tom's job was to start used cash register stores and undercut all the other used cash register stores' prices to run them out of business. When that happened, his store would close and people had to buy new cash registers from NCR. Also, according to the same biography, Tom went into a tavern for a drink but left his horse and wagon outside full of cash registers. Someone stole both his horse and wagon. From that point on, no drinking was permitted at any company he worked at. NCR got sued for their dirty tricks, and they blamed it all on Tom. It's his fault. It's his fault, so he got fired and ended up with possible jail time. He needed a job and was hired by Charles Flint at Computing Tabulating Recording, also known as CTR. They were willing to hire Tom, even though he had jail time hanging over his head. Somehow, he got the jail time dismissed. It was there that he worked with Herman Hollerith. You may recall that Hollerith was the punch card guy. Tom Watson worked his way to becoming president of CTR with a strong promotion of the punched card business. He wanted a better name for CTR, even better than the national NCR, and wanted it to convey more than cash registers. CTR was then renamed International Business Machines, now IBM. The punch card business thrived under Tom Watson Sr. IBM joined with Harvard University in building an electromechanical computer called the Mark I. Although it can be called a computer, it was not electronic. IBM was falling behind companies like UNIVAC, which started getting orders for computers to replace IBM's beloved punched card equipment. This scared one of the vice presidents, Tom Watson Jr., and he convinced his dad that IBM needed to get into the real computer business. The IBM 1401 was designed as a replacement for IBM's punched card equipment, or as an add-on helper to IBM's larger 7000 series computers. By the mid-1960s, nearly half of the computers in the world were 1401 type systems. Monthly rental for the 1401 configurations started at $2,500, worth about $22,000 today. That is for the base model with 1,400 bytes of memory. Consider that the base model for an iPhone is 64 gigabytes of memory, which is about 45 million times more memory than the basic 1401. IBM also built the 1620. It was named the Cadet, which stood for Can't Add, Doesn't Even Try. It was nicknamed this because the hardware did not have an arithmetic unit, but needed to do everything in software. The computer came with a card reader, punch, and a printer. My first experience in programming was the SPS language and Fortran at El Camino College in California. The school was able to get its hands on a 1620, possibly because it was becoming obsolete by then. Further development was stopped on the 1401 and the 1620 when IBM decided to build the System 360. This was such a major undertaking for the company that if this project failed, it would probably bring down the company. What is special about the System 360 is that it is a family of computers from low-end Model 20 to the high-end Model 85. Programs written for the Model 20 could be run on all the other 360s. This meant that customers did not need to worry about having to rewrite their software when upgrading to a better machine. The IBM 360 series was microcoded so that it could recognize different sets of machine instructions. This was done so that the System 360 could not only use its more advanced set of instructions, but could also be configured to use the IBM 1401's instruction set. Since the cost of the software sometimes exceeded the cost of the machine, and many of the IBM customers had already invested years of software development in the 1401, they could buy a more powerful System 360 and still run the programs written for the 1401. When you powered up to 360, it could be set to either 1401 emulation or standard 360. The microcode instructions were stored on a floppy disk inside the 360. It was like if you woke up in the morning and inserted a brain into your head that spoke French, or inserted a brain that spoke English, but you couldn't switch back and forth without reinstalling a new brain. Gene Amdahl was the chief architect of the System 360. He left IBM because he wanted to design a new computer and IBM didn't want to. So he started Amdahl Corporation, which built IBM-compatible computers, which successfully penetrated about 25% of the market for the System 360 type computers. The large IBM computers at that time were water-cooled, which greatly increased their cost. The Amdahl computer was air-cooled by using a large heat-sink tower on each chip. Gene Amdahl needed money to finance his company. Not many Americans were interested in investing in a company that would be competing against IBM. However, the Japanese company Fujitsu invested in Amdahl Corp., which is now wholly owned subsidiary of Fujitsu. I think Fujitsu was most interested in the advanced technology that Amdahl Corp would bring them. I worked at Amdahl for several years on the laser bonder project, where it was used to add wires to the back of the multi-chip boards. Remember Tom Watson's anti-booze rule for IBM? When Amdahl shipped its first computer, it was celebrated with champagne. One of the employees got into an argument with his wife or girlfriend or whatever and kicked her out of the car as it traveled down Central Expressway. I think there was a lawsuit. Well, so much for champagne celebrations. The floppy disk was designed by Alan Shugart. The original floppy disk was 8 inches. The next version was 5 1/4, and the floppy diskette was 3 1/2 inches. Floppy disks were so prevalent with the early computers that even today an icon of a floppy is used on many applications to save a file. After he worked at IBM, he went to Memorex. Later, he started his own company, Shugart Associates, and made hard disks for personal computers. Unfortunately, in order to get funding to start his company, he ended up giving away most of the equity in the company. So he started a new company, Shugart Technology, but was sued because it sounded too much like the company name Shugart Associates. So he changed the name of his new company to Seagate Technology. Seagate is the English translation of the German Shugart. He even launched an unsuccessful campaign to elect Ernest, his Burmese mountain dog, to Congress. By 1965, IBM dominated the computer business with over 65% of the business market. The rest was shared by Burroughs, Univac, NCR, Control Data Corporation, General Electric, RCA, and Honeywell. This became known as IBM and the Seven Dwarfs. In 1969, the United States of America alleged that IBM violated the Sherman Antitrust Act by monopolizing or attempting to monopolize the general-purpose electronic digital computer system market, and alleged that IBM's actions were directed against leasing companies and plug-compatible peripheral manufacturers. Shortly after, IBM unbundled its software and services in what many observed to believe was a direct result of the lawsuit, creating a competitive market for software. In 1982, the Department of Justice dropped the case as without merit. When IBM came out with the PC, they were very careful to show that it was an open architecture system that anyone could build upon. The Sherman Antitrust Act was passed to break up the Standard Oil Company. It was used again to break up AT&T. Investigations were also conducted concerning Microsoft and General Motors, and more recently with Apple and Google for their App Store and Google Play stores. A mini computer is a much smaller computer than the large mainframe computers sold by IBM and its competitors. They typically sold for around $25,000 or about $170,000 in today's money. When Intel developed the 4004 microprocessor, the term mini computer was referred to the mid-range of computers. Ken Olsen and Harlan Anderson co-founded Digital Equipment Corporation in 1957, known as DEC, also trademarked as Digital. DEC built several lines of mini computers. The most famous were the PDP-8 and sold over 600,000 PDP-11s and over 400,000 VAX-11 series computers. They ended up for a long time being the second largest computer manufacturer after IBM. As computer prices decreased, DEC kept their prices high and eventually were outsold by IBM PCs and Motorola. Edson DeCastro was chief engineer in charge of the DEC-8, but left with several other DEC employees to found Data General because it is rumored that they were frustrated with DEC's management. They designed and built the Nova, which was much cheaper and faster than the PDP-8. I didn't spend too much time working with the PDP-11, but I did spend several years on the Data General Nova. When we first started out, we needed to flip switches to select memory address and then start putting in the Bootstrap program by flipping switches to store the data for each memory location. One day, I read an article about a new computer that didn't have all the switches on the front panel. I was wondering how they would be able to even get the computer started. The solution came with a new type of chip called a ROM, for read-only memory, that doesn't lose its data when the power is turned off. The Bootstrap loader, some diagnostic and basic input-output routines were pre-programmed into the ROM at the factory. When programmed with these features, it is called the BIOS chip for Basic Input-Output System. Many other large companies decided to get into the business of building mini computers, such as HP, Varian, IBM, Texas Instrument, and Control Data, and others. The Apollo Moonlander program required a computer that was small enough and light enough to fit into the spacecraft. Computers at that time were big and bulky and weighed several thousand pounds, even ones made using transistors instead of tubes. The integrated circuit, also known as an IC, was developed independently at Texas Instrument and Fairchild. NASA's Apollo program was the largest single consumer of integrated circuits between 1961 and 1965. As the semiconductor companies were able to add more and more transistors to a single IC, they were finally able to build a full processor on a single chip. When a single chip contains the microprocessor, memory, and some input-output circuitry, it is called a microcontroller. The first microprocessor was the Intel 4004. Intel kept improving with the 8080, the 8085, the 8186, 286, 386, 486, and called their 8586 the Pentium to keep other companies from copying their designs and naming them by the same numbers used by Intel. Other companies developed microprocessors that were different from Intel's. The 6502 became the basis for the Apple I and Apple II, the Commodore 64, the Atari 2600 video game console, and many others. The 68000, later the PowerPC, were used for early Apple Macintosh computers. The 8080, 8085, and the Z80 by Zilog were used by the Altair and CP/M systems. IBM made the PC as open architecture, meaning that anybody could add custom boards to the unit. They figured by copyrighting the BIOS they could prevent companies from making clones. They successfully sued and drove out of business anybody that made a clone and just copied their BIOS chip. Compaq Computer successfully created their own BIOS that performed the same functions as the IBM PC. Phoenix and AMI created similar BIOS chips that they sold to clone manufacturers, enabling many companies to compete with a cheaper version of the IBM PC. The Xerox Alto is the first computer designed from its inception to support an operating system based on a graphical user interface, or GUI. The first machines were introduced in 1973. The Xerox Alto was hindered by its price of $32,000, or almost $115,000 in today's money. The original mouse was developed by Doug Engelbart. At that time, he wondered if it would even be used for anything. In 1979, Steve Jobs learned of the advanced work on the graphical user interfaces, GUI, taking place at Xerox PARC. He arranged for Apple engineers to be allowed to visit PARC to see the systems in action. Apple developed the Lisa computer and the Macintosh, which became the first commercially successful use of a GUI. Apple needed additional applications to make the Macintosh more useful. Apple teamed up with Microsoft for Word and the Excel spreadsheet program and Ashton Tate, the makers of DBase database program. This effort helped Microsoft develop its own Windows system, much to the anger of Apple. I probably could go on for hours about the history of computers, but I need to end sometime. I am grateful for the many stories and pictures shared on Wikipedia, and again recommend visiting the Computer History Museum in Mountain View, California. Check its schedule of operating hours. They may change based on human viruses that may be running around. Here is a list of credits for many of the pictures that appear in the video. If an image is not listed, it is believed to be in public domain. Bye. See you around next time.